Good morning, students. Today we'll discuss model number 3, partial differential equation. In a partial differential equation, we already discussed its basic part. So now we'll move with example. In example, we need to form a partial differential equation by eliminating arbitrary constant from a given example. This is the given equation. So we need to form, it is a formation of partial differential equation from a given example by eliminating arbitrary constants. So we can see here A and B are arbitrary constants. So these two constants to be eliminated. For that what I do, first I take the given example as it is. So ax square plus by square plus z square equal to 1 it is. So we'll make it as z square equal to z square is equal to 1 minus, take all these terms to the other end, then it becomes ax square minus by square, and it will be called as equation number 1. Now this is the equation. So here we can understand z is a function of x and y, where x and y are the two different variables, independent variables, where z is a function of these two independent variables, and a, b are arbitrary constants. So we need to eliminate these two arbitrary constants a and b from this equation. Then we can get partial differential equation which is free from arbitrary constants. For that what to do? First we'll differentiate equation number 1 with respect to x partially by treating y as a constant. If we differentiate it with respect to x partially, then what we get? So differentiation of z is a function of x and y, so z will be differentiated. So it becomes 2z into dou z by dou x, which is equal to differentiation of 1 will be 0 minus differentiation of a into x square. So differentiation of x square with respect to x will be 2x, so it is minus 2ax minus differentiation of by square with respect to x will be 0. Therefore it is 2z, and what we do, we take this dou z by dou x as a notation p. Here we take dou z by dou x is equal to notation p, then dou z by dou y will be taken as q, notation q. Okay, so this is equal to minus 2ax. Therefore as per this, on both sides 2 is there, it get cancelled to balance the terms, then it becomes zp is equal to minus ax. So which is nothing but a is equal to, if you find the value of an arbitrary constant a, then it becomes minus zp divided by x. So we call it as equation number 2. So we got a value for one arbitrary constant. Therefore, similarly, let us differentiate equation number 2 with respect to y partially. Again, we need to take partial differentiation. So differentiate equation number 1 with respect to y partially. Then it becomes differentiation of z square with respect to y will be 2z into dou z by dou y is equal to, again differentiation of 1 will be 0 minus differentiation of ax square with respect to y will be 0 minus differentiation of b into y square with respect to y will be minus 2by. Therefore this equation, as we discussed, dou z by dou y will be taken as a new notation q. Therefore it becomes 2zq is equal to minus 2by. Again 2 to get cancelled. Therefore we will be getting zq is equal to minus by, or else b, a constant b is equal to minus zq divided by y. We call it as equation number 3. If you see the equation number 1, here the value of a and b are required to eliminate these arbitrary constants, and we have ready with a value of a and b as equation number 2 and 3. Then what we do, Let us substitute equation number 2 and 3 in equation number 1. Then equation number 1 becomes, equation number 1 is z square is equal to 1 minus, z square is equal to 1 minus ax square minus by square. So substitute this equation number 2 and 3 as a counterpart of arbitrary constants a and b. Then it becomes the value of a, that is minus zp by x into x square, minus the value of b, that is minus zq by y into y square. Here when x get cancelled, y get cancelled. Therefore it becomes z square is equal to 1 minus of minus is plus zp into x, again minus of minus plus zq into y. Therefore what we do, we take this 1 to the other end, then it becomes z square minus 1 is equal to, z square minus 1 is equal to, from these two let us take z common, then it becomes px plus qy. So this will be the required partial differential equation. So if you see this differential equation, partial differential equation, it is totally free from arbitrary constants, and p and q are the notations taken in the beginning as dou z by dou x and dou z by dou y respectively. Even if you substitute those values also, it becomes z square minus 1 is equal to z into p is nothing but dou z by dou x into x plus z is common term plus q is nothing but dou z by dou y notation into y. Even we can say this is also a required partial differential equation. Either we can represent it like this or we can represent it like this. If you see both the equations here, there is no arbitrary constant available right now. Therefore we eliminated arbitrary constant to get a partial differential equation. So this is the solution. Thank you.